In the heart of Paris, standing sentinel over the capital, the structure once artlessly known as the 1,000-foot tower has become more than just a symbol throughout the world. It is the embodiment of France itself. This masterpiece was a triumph for one of the greatest visionary builders of the Industrial Revolution.
It was a huge technical challenge. You needed to be adventurous.
But hidden in the shadows of the tower, which bears his name, are many other great works built by Gustave Eiffel. Over just a few decades, his company completed more than 500 projects all around the world, and every one of them shocked the world of civil engineering.
Eiffel understood that by using more efficient construction methods, he could be a real threat to his possibly less inventive competitors.
His unique creative talent won him contracts for the most awe-inspiring building projects of his time.
The Maria Pia Bridge has played a globally important role in the development of civil engineering.
From far away, it looks like lattice work, like it's probably very light, very flimsy. But when you're inside the structure itself, you see just how incredible this structure is.
It was modern, it was totally new and innovative, and the whole building is so light.
From Paris to New York via Porto and Budapest, each of his designs was more impressive than the last. They sparked a new iron aesthetic which defined the emerging railway era.
He had placed the bars so high that many designers and engineers copied him.
He paved a new way for the architectural and construction industries because he went beyond the limits of what had already been achieved.
Nearly 100 years after his death, his buildings are still just as iconic, sturdy, and influential. How did Eiffel, project after project, turn the world of construction on its head? What groundbreaking ideas propelled him to the pinnacle of his profession, of his age? How has he inspired entire generations of engineers, leading to a century of advances? By looking at Gustave Eiffel's greatest achievements, we dive deep into the secrets of this master builder and discover the scope of his technical virtuosity, which compelled him to rewrite the rules of engineering with each new project. Eiffel, a man often described as the genius of iron construction, was first and foremost a man of his time, often ahead of his time, but always pragmatic. In 1852, at a very young age, he took advantage of his good schooling and mathematical abilities to study engineering. He was 20 years old.
Eiffel began his career as this brilliant engineer who'd been to the renowned École Centrale in Paris. Chemistry was his original chosen career path, but instead he turned to metal construction work, which at the time was a fast-growing industry.
The young Gustave Eiffel found himself in an industry in the midst of a revolution. It was the age of iron in France and Europe, and more precisely, it was the age of the railways.
The Great Railway Era was during the 19th century, when France was suddenly covered with an extraordinary rail network.
In 1857, Gustave Eiffel was given his first big project, supervising the construction of a bridge in Bordeaux. It was an ambitious task. The bridge needed to cross the Garonne River over a distance of more than 500 meters to connect France's two main railway networks, the Orleans Line and the Midi Line. It was quite simply the greatest construction project of the day. It was a dream opportunity for the young Eiffel to perfect his iron construction technique, and his experience would have a huge impact on his life to come. An assembly of pieces using rivets, St. Andrew's crosses, outsized metal beams, and river-deep foundations. Building the Bordeaux Bridge was a textbook case. But the project also revealed a fundamental aspect of the young engineer's personality.
Eiffel was very young. He was 28 when he led the building project, which was the biggest of its kind in France at the time. He had to be organized, and that's where Eiffel's talents as a company director, as a leader, were revealed. He even put his own life on the line, diving into the turbulent waters of the Garonne to rescue a worker who couldn't swim. He demonstrated his authority, and after the success of this building project, he was really standing on his own 2 feet.
Gustave Eiffel was ready. He had mastered all aspects of metal construction and was about to embark on the journey of a lifetime, the great age of iron and the railways. The second half of the 19th century had barely begun when things began to accelerate. Railway networks began spreading like wildfire throughout the country. Their progress was as quick as it was necessary.
At the time, there were no cars, no highways, so the railways acted as liberators, as it were, opening up different areas of the country, making them mutually accessible. It was very important that the networks went through places that were difficult to get to.
For industrials, as well as private individuals, it was essential trains could access every part of the country, even the most remote and sometimes the most inaccessible.
The challenge when developing a new railway line, or today when we're building highways, is to create a route that is as flat and as straight as possible. So, of course, you need to design a great number of artistic structures, tunnels to go through any mountains that might be in the way, and you also need bridges and viaducts to travel across valleys.
The railways needed a unique infrastructure in order to guide smoothly through the country's topography, and Gustave Eiffel was keen to contribute. When he was 32, he decided to create his own company. Thanks to his business sense, his organizational skills, and construction know-how, he won contracts for projects all over the country. His constructions were reliable, robust, expert examples. And they extended beyond the context of the railway networks to include all types of metal construction work. Gradually, the company grew, and Gustave Eiffel started looking for an associate as well as further capital.
He found an associate who was perfect for the role, named Théophile Seyrig, who provided a large amount of capital for the company's expansion, as well as his expertise. Théophile Seyrig was an extremely bright valedictorian from the École Centrale. He was highly skilled where the design and calculations of a structure were concerned. This meant Eiffel could move things to the next level.
With Seyrig on board, the Eiffel Corporation was launched. The two men began to prepare for one of the business's most beautiful achievements. 1875. It wasn't in France, but in Portugal, that the business would first shine on the world stage. The Royal Company of Portuguese Railways needed to connect the north of the country with the south. The main line needed to cross the great river Douro, which went through Porto. In the center of the city, the Douro expands on its way out to the coast. One thing was obvious. The bridge across the river could not hinder the movement of traffic on the river, which was vital to Porto and the surrounding area. Eiffel and his young associate Seyrig needed to do something bold. They designed the longest single-arch span bridge ever built, the Maria Pia.
The bridge's most distinctive feature is its arch. That was the revolutionary element. The other bridge elements were mass-produced, which was industry standard in companies like Eiffel's, and didn't present any particular problems. The main problem was how to design an arch that crossed the 140-meter river span, which would withstand the wind, as well as trains coming and going over the top of it.
This metal arch is 160 meters long and is held up by solid stone foundations. Up above, it supports a 352-meter-long horizontal deck, and its summit is more than 60 meters above the water. Because as well as crossing the Douro, the bridge had to connect the cliffs bordering the river in order to extend the railway line at their summit. The entire construction was reinforced with pylons placed at regular intervals, some supported by the ground itself and some supported by the arch. But there's one particular detail that makes this bridge so brilliant and unique.
It's a very delicate-looking bridge. It's almost iron filigree, and yet it's secure and sturdy. But the most surprising technical factor was Seyrig's idea to fix the deck to the arch. He was the only person to come up with this design for metal arch bridges. I call it Seyrig's secret.
Fusing the arch and the horizontal section together gives the bridge an almost organic quality. At the very top, the different elements join together to become one. It's a bridge that's as beautiful as it is resistant, and people still marvel at it to this day.
The Maria Pia Bridge is an example of what this new metal architecture, iron architecture, was capable of, creating new shapes and architectural structures, which would create new landscapes, with this highly visible explosion of technical achievement in an otherwise natural environment.
With the brilliant Théophile Seyrig by his side, Eiffel created his first masterpiece. He established a new standard for big-scale railway bridges. But behind this very iconic look, it's the way in which the bridge was built that was the real source of inspiration for the construction revolution. In 1875, the Royal Company of Portuguese Railways did not commission Eiffel directly. Instead, it put out a highly competitive international tender. Eiffel applied and found himself up against three of the biggest construction giants of the day. And thanks to his perfectly calculated design, he won. His idea was to build from the banks outwards, using the cantilever method. The two parts of the arch and deck would be gradually erected on each side of the river, held up bit by cables attached to the pylons, as well as hoisting systems. Gradually, the two structures would travel out into the open space above the river and join in the middle. This technique would not require a scaffold to be built in the river, which would have been both costly and time-consuming.
Eiffel's genius was that he understood that by using more efficient construction methods, which were also cheaper and quicker, he could be a real threat to his possibly less inventive competitors. And so, the project put forward by Eiffel's company with Seyrig was the least expensive by far, 3 times less so than his most expensive competitor. That made Eiffel stand out from other metal construction companies.
The Maria Pia Bridge has played a globally important role in the development of civil engineering, and this was not only recognized at the time, but is still recognized today. It still represents a watershed moment in understanding the technical development of world-class civil engineering.
Building the Maria Pia Bridge extended Eiffel's influence on the construction industry dramatically. His company had reached construction giant status once and for all. (1874). At the same time, on the other side of Europe, the recently established and powerful Austro-Hungarian Empire was also developing its railway network throughout its lands. The city of Budapest was the center of attention. It needed a new station.
Because of the long-term plan of the railway company, and because of the long-term plan of Budapest, they decided together to build a bigger and a more representative railway station in the heart of Budapest. So that time was a huge vibe in the city.
The Austro-Hungarian authorities were about to build the monumental Nyugati train station. The building centers around a huge 14,000-meter cube metal entrance hall. Its facade is a huge wall of glass, giving the building a view of the city. On each side, the construction is framed by buildings which bring together brick and metal, with turrets that overlook the great entrance hall. This vast station and its hybrid structure was to reflect the empire's achievements and modern values.
It was modern, it was totally new and innovative. Because of this steel structure, they can handle the width of the hall, and the whole building is so light because of there's no massive structures. And the construction took around 3 years, which was really fast, because that time it was the biggest building in Austria-Hungarian monarchy.
To construct such an impressive monument, the public authorities wanted the best, and Eiffel's company was ready to accept. This time, they weren't the designers, they were the builders. Aside from the great steel sections which he had produced in France on his own factories, Eiffel also had to supervise every aspect of the construction process. The stonework, the bricklaying either side of the entrance hall, as well as the ornamental elements covering the walls.
Pest Station was the crowning glory of his business career and showed his ability to take charge of construction projects, which were undoubtedly more complex, more varied at any rate, more diverse than sites that only involved metal structures.
The success of the station in Budapest brought with it the dawn of a new era for steel construction. Iron was no longer only used on railways and their infrastructures. A new architectural style had arrived. For Eiffel and his company, it was a chance to be part of more and more prestigious building projects. In 1876, the French bank Crédit Lyonnais began building its Paris headquarters. A colossal building designed to display the bank's financial power in the heart of the city. Behind its very traditional appearance, the building's interior architecture is much more unusual. Eiffel was responsible for the vast entrance hall, a huge nave-like space topped with a sumptuous glass roof. Thanks to this, the entrance hall was flooded with natural light. The whole building was crisscrossed with pathways made of wrought iron leading to offices, which at the time were completely open. It was a building at the very forefront of modernity. On the other side of this structure, in the main building, stonework dominated. Or so it seemed. Here, Eiffel erected a metal framework to support the whole building. It was discreet, but the connection between this more traditional section and the great metal entrance hall created a strange rotunda topped with another glass roof.
What I find so wonderful about this space is that this circular shape is quite unusual, and it has a functional role, marking the join between the main building and the great nave behind it, which is really diagonal to the main building.
This rotunda is packed with architectural marvels, representative of the era. The huge double staircase stands in the middle, separate from the rest of the building. Its double revolution effect allows for two streams of people to go up and down without ever meeting. It's a very traditional aesthetic. But as you ascend, metal elements start to subtly appear, becoming more and more obvious.
This is interesting because we're at the meeting of the stone and iron sections. The stone section symbolizes the traditional, classical architecture and also expresses this Great Bank status. And there's this iron section, which has been very carefully conceived, which is visible, and is sort of secondary, elongating the space behind this magnificent staircase, as well as echoing the metal roof sections. And so there's this very skillful integration of the two, as if the iron is also a traditional material in its own right, and complements the classical qualities of the stonework, expressing a fully accepted vision of modernity.
Iron as a representation of modernity becomes more apparent with every step. The glass roof provides the perfect finishing touch to the building.
And actually, you can see the space in between. It's separate from the secondary metal exterior staircase, and it's also separate from the dome, which is bigger. From below, it looks like the dome is resting on this section. These great glass roofs became more common from the 1870s onwards, especially between 1880 and 1900. And they were achievable thanks to a convergence of progress between the grand-scale metal construction industry and the smaller-scale glass industry, which later also developed, forming a metal-glass collaboration that could build transparent and translucent glass structures, which were really the hallmark of the architectural style of the end of the 19th century.
With its grand interior spaces, its multiple glass structure, its mix of classic and modern architecture, stone and steel, the construction of the Crédit Lyonnais headquarters marked the dawning of a new age. Eiffel was now a major player in the construction industry and proved he was more than capable of any project. From then on, he was the first port of call for the most challenging projects, both in Europe, but also on the other side of the Atlantic. The construction of the Crédit Lyonnais headquarters was not yet finalized when Eiffel was asked to work on a unique project of great diplomatic importance. France wished to gift a huge statue to the United States of America.
The Statue of Liberty was designed by sculptor Auguste Bartholdi, originally from Alsace. He was a Republican who, along with other Republicans, wanted to show his respect to America. It was a tribute to the American Republic, to the American Constitution, which served as an example to French Republicans. The design was a gradual process, and the project evolved over time to become this monumental statue, the Statue of Liberty.
46 meters high, standing atop a 27-meter-high pedestal right in the middle of New York Harbor, this legendary work of art would confront some unusual technical difficulties. The statue had to remain stable when exposed to the elements and be sturdy enough not to collapse under its own weight. The structure, which would hold up the copper exterior, had to be resistant, flexible, and light. An effective, perfectly adapted solution was needed. The heart of the metal structure is one solid mast, born of Eiffel's expert knowledge in designing bridge columns. The mast has 4 sides, reinforced at regular intervals with St. Andrew's crosses. A second structure is fixed around this first sturdy column, giving a more precise outline of the statue's form. To perfect this iron skeleton, Eiffel decided to add a number of flexible metal strips to the secondary structure, which were fixed at one point only in order to remain relatively mobile. Their job was critical. The statue's copper finish would hang from these strips. They helped the exterior to support its own weight and allow the statue some flexibility of movement once it was exposed to the elements.
Something sturdy in the middle and a lot more flexible at its extremities, which meant the statue could withstand the wind, moving a little, expand in the heat of the sun, and therefore have flexible qualities as opposed to staying rigid. And Eiffel's intervention transformed the statue into a great work of art. He guided Bartholdi, if you like, in his creation of the statue, which was first built to completion in Paris. You could see it in the Parisian skyline. Then it was taken apart, packed up, and sent to New York, where it was permanently erected.
It only took 3.5 months to build this enormous statue in its final resting place atop its pedestal. 300 copper sheets, 120 tons of iron, and nearly 300,000 rivets were used to erect a statue that has been a symbol of the United States for nearly 140 years. Despite its success and renown, the Eiffel Corporation did not rest on its laurels. While some of its employees were working on the mast for the Statue of Liberty, Eiffel was called upon for a project that would have a lasting personal effect. 1880. In central France, in the middle of the Massif Central, the railway connecting Paris with Béziers was about to reach the gigantic Truyère Valley, which was particularly deep and wide. The engineer responsible for building the railway only had one solution for crossing the valley: call the person responsible for the engineering feat that was the Maria Pia. Eiffel, who had first taken the railway construction industry by storm in Porto, was being asked to repeat his stroke of genius on an even grander scale. He was about to take on the contract for the Garabit Viaduct. Its 364-meter horizontal deck overlooked the valley from 122 meters up. The colossal arch, copied from the Pia Maria, was built much higher and much more quickly before descending down to the other side of the valley. This time, the deck was not fitted to the arch, but remained visibly separate from the rest of the structure. Its width supported the secure movement of the trains and also left spaces just underneath for a maintenance bridge the length of the viaduct. Thin spiral ladders were added to each of the 7 pylons. The structure's durability was a priority.
From far away, it looks like lattice work, like it's probably very light, very flimsy. But when you're inside the structure itself, you see just how incredible this structure is. This viaduct is pretty unusual because it's so airy. It's a perforated structure. You can feel it when you're at the top. The wind. The wind definitely holds a presence. And to overcome the power of the wind in this valley was an enormous challenge for Gustave Eiffel.
In order to build such a structure, Eiffel made use of every ounce of knowledge he'd acquired up to that point. As with the Maria Pia, he used the cantilever construction method, starting from each extremity. But with one difference: a temporary maintenance bridge was erected in the valley as a way to get workers and materials across a very uneven terrain quickly. The 2 sections of the enormous arc were built on each side of the valley, with the deck being constructed at the same time. Each part would have to meet each other in the middle to the nearest centimeter.
What's incredible to imagine is that people were building this viaduct in such extreme conditions. Winters weren't like they are today. Construction lasted 4 years. They were working in difficult conditions, in a much less secure environment than would have been assured today. So, this viaduct represents a really extraordinary human story.
The success of the whole operation, which took place over 4 years, relied on one final element, one of Eiffel's original and greatest qualities: the precise prefabrication of each single piece of the viaduct at the factory. Hundreds of thousands of different iron-made elements, which needed to be perfectly calculated at the design stage to the nearest tenth of a millimeter, so that all they had to do was assemble them on site, like giant Meccano.
What's so impressive about Garabit is the precision with which the elements were made in the factory to render the on-site construction part of the job that much easier.
Such a feat required a very skilled designer. Unfortunately, Eiffel could no longer rely on his associate, Théophile Seyrig, who had latterly become head of his design office, responsible for calculations. The two men had separated after a financial disagreement just before work began. Eiffel knew he needed to hire someone equally talented as quickly as possible. So he recruited a certain Maurice Cuquelin, a skilled engineer who managed to repeat the success of the Maria Pia at Garabit and create a new masterpiece. He would also play a key role in the corporation's next project. In 1884, the Garabit project ended, and in 1886, the Statue of Liberty was finally and definitely assembled in New York Harbor. Eiffel's company was widely sought after, but one particularly important year was fast approaching. 1889, the year of the next World Fair, which was to be held in Paris, and it coincided with the 100th anniversary of the French Revolution. It felt important to mark the occasion. At the heart of the corporation, its two senior engineers, Maurice Cuquelin and Émilie Nyugati, had been nurturing a slightly unusual idea to construct a 1,000-foot tower more than 300 meters high.
This idea was in keeping with the spirit of the time. Modern technology meant it was achievable, but it was still easier said than done. Cuquelin and Nyugati produced a fairly simple design, in fact, quite basic, for a tower using 300-meter-high pylons. They showed it to their boss, and you can imagine the scene. He takes a look. Yes, very good, boys. Interesting, but don't spend too much time on this. Nights and weekends, if you like, sure. So he wasn't all that convinced.
Through persistence, they managed to seduce Eiffel. Another never-before-seen structure. How could he say no to his most faithful engineers? After all, he trained them himself and encouraged them to think beyond the limits.
He knew his engineers were talented. He had the factories, he had the know-how, but it wasn't just a question of making the project a technical reality. Designing, calculating, and planning it, it also had to have a legitimate role in the 1889 World Fair, which would take some convincing.
After months of negotiations, Eiffel did convince organizers, offering to pay for a large part of the construction costs himself. The story of the 1,000-foot tower could unfold. Tens of thousands of designs were completed under the engineer Cuquelin's direction. Everything had to be perfect. Each of the 18,000 pieces and the 2,500,000 rivets were designed and made to the company's usual exacting standards. The building work took just 20 months. A construction that was higher than anyone had ever seen suddenly dominated the Paris skyline. This tower was the pinnacle of Eiffel's endeavors. 4 pylons connected to 4 ridges with St. Andrew's crosses pierced the sky. An open lattice wrought iron tower that was both light and strong. Held firmly together with rivets, it stood on solid foundations under the Seine riverbed, much like a bridge in a river. And to top it off, its curved shape meant it could withstand any strong winds, something Eiffel had become expert at. On March 31st, 1889, the world's tallest tower was ready to represent France.
The Eiffel Tower is sort of a paradox. He didn't design it. It carries his name, but it wasn't his design. It wasn't his idea. But that idea needed to become a reality. And that's where Eiffel was really unique. Even though he didn't design the tower, he was the one to build it. He turned a relatively loopy, abstract, and utopian idea into a reality within a limited amount of time.
With a tower named after him, Eiffel had well and truly reached the stars. And yet, just as soon as it had been built, the businessman had already turned his attentions to another project, the construction of the Panama Canal. A colossal undertaking, the aim of which was to connect the Atlantic and Pacific Oceans. A few years earlier, Eiffel had been commissioned to build 10 giant locks for the length of the canal. It was a task that reflected his now world-class renown.
Eiffel took on this commission, which was by far the biggest of his career, just huge, around 15 times more costly than the Eiffel Tower. He started to build the gates for the locks, these huge 11-meter gates. They were the biggest ever to have been built. But having started the job, he didn't have time to finish it because his company went bankrupt.
The construction site itself was a fiasco. Workers died of malaria, conditions got worse and worse, and the project got further and further behind schedule. In the end, the company behind this crazy undertaking struggled to come up with the funds needed to finish the job. Construction was completely halted, and everyone prepared for the biggest financial scandal of the century to erupt.
And so people reproached him for earning a lot of money from a project where others had lost out in a big way. He was taken to court and sentenced to prison with the right to appeal. On appeal, the case was overturned and he was cleared, but still, for him, it represented a very great and a shameful disgrace.
Aged 60, Eiffel had grown sick of the world of business. He stepped down as director of his own company, requested that his name be removed, and handed the reins over to his trusted right-hand man, Maurice Coquelin. The company was renamed L'Evalué Perret Constructions, and Eiffel left the industry for good. Despite this painful episode and his early retirement, Eiffel's incredible contributions to the metal construction industry will always remain a source of inspiration.
He was one of the great protagonists of this construction revolution, this revolution of iron architecture, and the Industrial Revolution too. He successfully completed between 500 and 600 construction projects. That's Eiffel's legacy too, a construction legacy which makes him one of the greatest builders of the 19th century, certainly in France, and maybe even the world.
Eiffel had hundreds of completed projects to his name. Crucial railway bridges, works of art each more majestic than the last, and buildings at the pinnacle of modernity. But on top of these incredible structures left in his wake, one very particular form of infrastructure would soon follow in the footsteps of his legacy. At the dawn of the 20th century, the railways he himself had helped build were headed full tilt into the centers of the world's greatest cities. And in 1900, the Paris Metro was born.
At the time, there was a huge focus on Paris, which had sort of become the center of the world. Paris was becoming blocked. You could see at every World Fair that transport systems couldn't handle the influx. A much bigger, speedier transport solution was required that could be built away from the clogged-up surface of the city.
Building projects began at the four corners of the capital, and more impressive construction sites appeared on the streets of Paris. Skirting around buildings, the original infrastructure quickly became an integral part of the city. And at certain key locations, the Paris metro stood out thanks to its architectural features.
It was a time when people made bold construction choices. For example, the bridges across the Seine before people dared to create tunnels under the river. The Berkheim and Bercy bridges, above which a separate level was created for the metro. It made for a unique cityscape. Nowhere else in the world would you find bridges over a river with a metro line on another bridge above the first bridge. That was unheard of. Except it's what they did in Paris.
A third and final structure would join these two unique crossings over the Seine. A remarkable railway bridge, the form of which was modeled entirely on Eiffel's legacy, the Austerlitz Viaduct. (1903). To connect Austerlitz Station to Quai de la Rapide metro station, Paris needed a structure over the Seine that did not require too many support pylons in the river itself. The aim was to avoid hindering river traffic as much as possible. And so a radical choice was made. The structure would have bank foundations only. At 140 meters long without any intermediary support, it was to be the longest bridge in Paris at that time. Once again, only iron would hold over such a distance without the risk of collapse under the daily weight of the jam-packed metro carriages.
The know-how that had been developed since the middle of the 19th century was just incredible. This is about 12 years after the Eiffel Tower, so it's a technique which had been expertly grasped by some extremely impressive construction companies.
A tender went out, which was won by a very well-known company who were experts in the field. Les Valois-Perret Constructions, successors to the Eiffel Corporation, directed by Maurice Coquelin. Who better to take on this project than the man trained by the master of metal construction himself? Between 1903 and 1904, a perfectly orchestrated construction site was set up in the middle of the Seine. As the work progressed, the refined shapes of the bridge began to appear. The different elements started to come together, and the two arches were erected. The elegant form of the viaduct took shape. It's a structure that even today never ceases to amaze.
Here's a Line 5 metro heading over the Austerlitz Viaduct. A totally normal scene in Paris, but nevertheless a breathtaking one. It's a magnificent construction, and you can see the balance between the viaduct and the Parisian landscape. The designers came up with a structure that is held up by an arch, which is actually made of several pieces, even though we can't see any of the joints. It's amazing.
The Austerlitz Viaduct is more than just aesthetically beautiful. Faithful to its mentor Eiffel, Coquelin used an innovative technical solution that was crucial to keeping the structure aloft. The viaduct's two arches have three joints, one on each side of the river, another just above the deck, and a third on top, which also serves as a point of focus for the pressure exerted by the trains crossing the structure. This design allows the viaduct to evolve, to remain flexible and react to the movements of the train traffic without giving way under the weight of it. A steel reed which can bend under pressure.
The train coming over now is heavy. It's putting a lot of pressure on the bridge. The deck is pulling on the arches. And now the train's going to brake, and in doing so, it's going to jolt the bridge forward slightly. But you can't see that happening. And the whole structure stays upright because the bridge has flexibility. It's articulated at these joint points in the middle and at the sides. It's a genius design, and it's been working for nearly 120 years.
Today, about 700 metro carriages come over the bridge every day. 700 metro carriages, meaning several dozen heavy axles, too. Imagine that load day after day, year after year. So yes, these are extraordinary examples of engineering.
10 years after Eiffel retired, his successors were already making their mark. In the heart of the city, railway bridges were becoming more and more technical, as well as painstakingly decorated in order to stand out as masterpieces in the artistic sense of the word, too.
Eiffel was the influencer of the day. He had placed the bar so high that many designers and engineers copied him.
The new metro infrastructure encouraged engineers and architects to create structural works of art on a city-wide scale.
When we talk about the Austerlitz Viaduct, the star of the show is the viaduct itself, but urban planners know that actually it's the whole section of the line that is quite exceptional.
Before it reaches the sign, the metro line which crosses the city goes via Orleans Station, now Austerlitz. It had been built a few decades previously, and there were no questions of it being moved. It was therefore decided that the metro would run straight through the middle of the building. The rails literally pierced through it, and a station was built underneath the giant glass roof at the very top of the building. As it leaves the station, the aerial railway line continues, connecting with the celebrated viaduct. On the other side of the river, there is one final peculiarity. The line dips underground in a sharp curve before emerging out into the open air once more at Quai de la Râpée.
The configuration, perhaps over 1 or 2 kilometers, from the Boulevard d'Hôpital up to Boulevard Bourdon, is extraordinary. It's like urban lace. It's something that merits every urban planning award going. It really completes the exceptional nature of the whole design over which the Austerlitz Viaduct reigns.
The proliferation of these urban structures, each more adventurous than the last, would forever leave their mark on the face of the city.
People live at Austerlitz. People live at Quai de la Râpée and Bastille. They weren't just metro stations. They were a new way to map the city.
Iron and metal construction continue to shake up all aspects of everyday life. Thanks to progress on the railways, the building projects of the 19th century redefined the way cities were organized as well as the rest of the country.
It really was the century during which the Industrial Revolution started, and it founded the current model for society. All our economic, social, demographic, political, and cultural progress stems from the 19th century.
Eiffel's genius helped bring about this revolution. He built works of art for a new era, spanning the widest of rivers, conquering the loftiest of heights.
This collection of single-arch iron bridges is unique. There are no others.
His legacy reveals a collection of even more adventurous, even more majestic bridges that have been built all over the world.
Eiffel was a leader, as we would say today, of the iron industry, and he had an influence over his entire era, together with his assistants, those who left him, those who were his competition, all of whom were experts in this amazing material, iron.
Over the years, this master of metal construction touched every industry with his work, transcending the limits of the imaginable.
Gustave Eiffel certainly liked a challenge and to try to do things that had never before been attempted.
This 300-meter tower proved it was possible to build 300 meters upwards. This idea of a metallic skeleton, like the one in the tower, but perhaps hidden under stonework, terracotta, brick, or even glass elements, was a leading example of a much lighter metallic structure which could reach much greater heights.
The age of the skyscraper was round the corner. All over the world, his successors copied his techniques in order to attempt the impossible in their own name. Eiffel's achievements paved the way for the 20th century and changed the science of engineering forever.